So while I find out this screen share, just let me say I'm so happy to be here today in the evening here and in the morning for some of you, I guess. There's a bit of echo. Oh, you got it. Good. So we're here to talk about data lies and how we can spot deceptive data stories or how we can spot manipulative data stories. And it's actually a topic that's that I'm quite passionate about. Actually, I think there's it's often kind of overlooked that data can be highly deceptive, and that data can be highly deceptive, even if we don't want it to. It's not always about the bad guys out there trying to manipulate us. But yeah, more on that. So I'm 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 surprised that's the one line you got from the bio. I'm a self-proclaimed data fanatic. You could say that is indeed true. But more on that, I'm a data architect with quite a diverse, non-traditional background actually. My career started back in the Royal Danish Air Force. I at some point grew tired of doing very operational stuff and wanted to be more on the development side, wanted to create new things, wanted to make improvements. And I figured that I needed to pursue that elsewhere. So I went on and studied to become a product development and innovation engineer. And for a long time, I thought that I was supposed to go out there in the world and create these great physical products that you and me and every one of us could use in our daily lives. I did that for a bit and was okay with that. That was fine. But at some point during that time, someone went into my office and handed me a project that was labeled something with IT and data. And from that point and onwards, I just never looked back. I've been working exclusively with IT, data, and specifically BI ever since, as in-house consultant, as an external consultant, and now as a business intelligence architect. And I just love going to new clients, seeing how their businesses and their business models can be completely transformed by putting data at the core of their business. So I really am passionate about that. And that actually also is linked to this presentation, because I think we all have a responsibility when we are creating these awesome reports, these reusable modular data sets, data warehouses, maybe even lake houses. When we are creating these objects, I think we need all to be very certain on why we're doing that. What effect the things we are creating are having on our organizations, on our own work life, and on, well, the world around us. I mean, of course, some of you are maybe working exclusively with data engineering, others may be working with reporting, and some third part of this puzzle. But I think as a whole, we just need to be very focused on that everything we do at the end of the day creates some effect out there in our organizations. Because if we just create data and data artifacts for the sake of data or for the sake of technology, I don't think we are even remotely pushing the boundaries of what data can help achieve out there in the world. And honestly, we can actually make matters worse than if we did do nothing, if we are not very aware of what we're doing. So If the objective here is to go from data to insights to actions to some effect, that's pretty straightforward, and that seems pretty straightforward to do, but there's just so many steps along the way where things can go wrong. I mean, what if you take a big decision in a business and the data behind that business or that decision was being manipulated or was just directly accidentally wrong? I mean, then that whole decision was taken on a wrong assumption, on a wrong foundation, and may come back and bite you in the bottom. So that's why I think this session is important, not only for people who are actually doing the decision making, but also for people who are preparing the data, for people who are gathering the insights, for people who are turning this into actions out there. Because if each and every one of us is aware of our responsibility for creating good data, and at the end of the day, creating good effects out there, we can make sure that we give the best shot at making decisions, process improvements, stuff like that, that will benefit ourselves, our companies, and the world around us more than it will create losses. So in this session, we're going to put on this kind of the black hat way of thinking. We're going to learn, or the white hat way of thinking. We're going to learn how we can avoid being manipulated at each and every one of these steps along the way by considering what we would do if we were in the shoes of the bad guy. So let's dig into that. I have an agenda prepared for today. We just went through the introductions. Then we're going to look into some preparations. Have a very simple framework for how you can evaluate the severity of any given type of data manipulations. The list of what are the attack vectors, where should we check for vulnerabilities and stuff like that. And then we'll go through the observations. And I know adding the agenda here like that, it seems a bit maybe a bit boring, but I promise you, when we get to the observations part, it's going to be filled to the brim with examples, funny examples of how data can be manipulated, amusing stuff, and so on. And some of them are even being sent to me by former viewers of this same session. And if any of you out there are sitting there just with this awesome example of some data manipulation that you have experienced, just feel free to send it to me, because I really love putting stuff in this presentation that is coming from you guys, the attendees. That just make the presentation even better. And then when we've been through all of these things, how data can be manipulated, we're going to look at what can we do to prevent it. We're going to round up and do a traditional Q&A at the end of the session. So in the meantime, if you have any questions, just feel free to put them in the chat during the presentation. We have plenty of time today, so we can just take them when they arrive and have a small discussion and then move on. And I'm sure Kevin will break in and ask the questions for you if you just type them in the chat.
You know it.
Yep, that's great. Well, with that being said, I think we should start look into the preparation part. So, preparations. I brought here a famous quote. If I had 4 hours to chop down a tree, I'd spend the first 2 hours sharpening the axe. So that is exactly what we are going to do now. We're going to sharpen the axe and prepare ourselves for data deceptions. And the first thing I have here is this this framework of the severity of data deception. So at the simplest level, we have knowledge share, the most innocent piece of data manipulation. Knowledge share, me sending something to you guys, you sending something to me, someone posting something on LinkedIn, someone sharing with a colleague a great idea they had or a piece of data that they found interesting. Just all plain regular knowledge sharing. Very innocent, can still cause problems. And it's a large problem actually these days with the growing internet, not with the growing internet, with the growing use of the internet, because if we are not being aware of what manipulation and deception that we are being exposed to, we may accidentally, in good faith, share bad knowledge and bad data with others. And by doing so, we innocently actually spread all this misinformation. So even though something is innocent, doesn't mean it isn't bad. So in the next step, we have plain old persuasion. I may send you some information. It may deliberately have been scoped, chosen, tweaked, just for the sake of changing your opinion on something. It could be trying to sell you something. It could be trying to get you to vote on a specific person. It could be persuading you into making a specific business decision in a specific scenario within the organizations. There's tons of ways that persuasion is going on. And some are, of course, more innocent than others. There's almost always a degree of a bit of a selfishness in true persuasion, but it's also kind of necessary. I mean, if no companies were able to do selling or sales or persuade other companies to buy their products, I mean, how would the world look like then? So still a bit innocent, but yeah, a bit more severe. And then we have plain old exaggeration. So almost similar to persuasion, but that we actually build on top of our data. We don't just take it as it is. We manipulate it so it appears to be more exaggerated than it is. There will be some examples later, but I think you have all, yeah, I think we do this actually in our daily life, all of us as well. Telling a colleague, I'll be there in 5 minutes, even if we know it'll take 7. That's an opposite way of exaggerating. Or, yeah, saying that, yeah, I think you know what it's about. So if we step up the ladder here, there's also actually disinformation. So now we're getting into the territories of actual lies and telling stuff that are plain wrong. Where exaggeration, we just tweak the truth. In disinformation, we completely neglect the truth and just tell you something that are plain wrong for the sake of changing your opinion. And at the top level, we have criminal fraud. And clearly, the more you step up this graph, the more severe it gets, the less innocent it is, and the more there's a chance that you can actually have a real punishment for partaking in this. So as you can see, data manipulation can range from being very innocent, very unintended, to being very harmful, very malicious, and very much with intent. That being said, intent or no intent does not really decide if something is as effectful or not. So as a person and as a company and as a world, we should be aware of all types of misinformation, from fraud to just plain old sharing of knowledge that hasn't been vetted. All right. Yeah. So we move on to and actually go back to the whole list here of data. So data must be turned into insights, into actions, and in order to actually have an effect. So as I see it, this is also our attack vectors. If we want to manipulate some data, so again, yeah, let's just pretend that we want to manipulate the data. Of course, I don't doubt that any of you listeners here are interested in actually doing data manipulation. I would not encourage that in any way, but I think it's important that we try to look through the lenses of how we can do it so that we can detect when it's being done. Also, so that we don't do it without recognizing ourselves. So the first vector is during the data collection process. Of course, things can go wrong there. Things can be manipulated. Things can be, accidentally just we have a bad quality. A lot of steps can go wrong in the data collection process. During the insight process, the storytelling itself can be as objective as it can be, or it can be very subjective. And that whole gray area, of course, leaves a lot of space for manipulation with the insights. And when you then have to turn these insights into actual decisions, there's also a big context. What is the context that the insights are being delivered to you in? Is that context being selected? Has it been manipulated? Has it been architected? I mean, what is this whole scenario? So I think that is the three main attack vectors of data manipulation. So that's the framework for you guys. I'm going to move on to actual observations, actual examples now, the juicy part of this presentation, where we actually see some examples of data that's being used in a deceptive manner, innocently or not, doesn't matter. Data that is being used in a flawed manner. Oh, do we have any questions so far? Now would be a good time to write them out before we move on. Otherwise, I'm just going to slowly move on to the next part.
Looks like you can move on.
Yeah, great. So, observations. Let's start with the data collection process and look at what we can do here to manipulate with the data. Again, we're looking through the eyes of the bad guy. What can we do? What can we do? So, the first thing I would look at would be, where are we getting the data from? Can we manipulate the sampling of where we're getting our data? There's one example that always comes to my mind when we talk about sampling manipulation. I think maybe it's the same example that you other guys are maybe thinking of. The classical 9 out of 10 dentists recommend some toothpaste. We also have I think this is the first ever example of this kind of thing, this kind of statistics about some teeth gum product. So anyway, 4 out of 5 dentists surveyed recommend sugarless gum for their patients who chew gum. So how do we achieve that? And how can it be that all the brands of toothpaste, they all have kind of the same statistics here? They all have that 9 out of 10 dentists recommend their toothpaste. Well, of course, they haven't asked the entire world. So take the brand in scope here, or any other brand, and say we want to achieve a commercial like this. Well, what we should do is go out there in the world and ask a few people. Hopefully, we'll start with a small sample size. Maybe we ask 10 people, and if 6 of them recommend our toothpaste, we maybe expand the survey and ask 100 instead. And then we quickly realized that, okay, that's only getting us to maybe 70 out of 100. So we scrapped that survey. That was clearly a bad research. So we just make a new one, ask 10 people, and that says 7 out of 10. That's bad again. We scrap it, start a new one, and ding, ding, ding. The third one gave us 9 out of 10 that recommended Sensodyne. How fantastic! We did an actual survey. 9 out of 10 responded that that our toothpaste was the best one. So we can publish it. But wait a minute, you say, maybe just maybe someone would question this. I mean, what if we did write this and someone actually asked us what the sample size was here? That would lead us into some troubles. So this is maybe an easy way out to get these results, but nevertheless, it's probably not the best. We will easily be caught out if someone asked us what is the actual sample size of this research, and we had to say that was 10. So what could we do instead? We could do some cherry picking. We can either do some cherry picking by asking a very, very well formulated question, or we can go to a specific group. So again, let's say we're a brand of toothpaste, and we want to have a a good statistic like this, 9 out of 10. That's our intent. So what about instead of asking random dentists, then we ask the dentist that we are affiliated with, or we ask random dentists at a conference that we happen to be arranging ourselves, so we know the audience will be at least skewed towards our brand. Well, suddenly you have, instead of manipulating the sample size, you have manipulated the sample selection. And the last thing is you can ask a very specific question. So in this case, someone got dentists to recommend chewing gum, and gum is not necessarily good for your teeth. But what they did is ask the dentist, would you recommend some patient who's already chewing gum to chew sugarless gum? And even though gum in itself could be bad for your teeth, most dentists would actually say yes to that. Yes, sugarless gum is better than regular gum. But it appears like they're actually, as a whole, recommending you to use gum. So again, manipulative but clever marketing being done here. That's one part of data collection. We can influence the sampling. Another part is nudging. And nudging is a sneaky little trick. Because when you ask people a question, you may not always want them to answer objectively. Maybe you sometimes want to actually control what they answer, or at least push them in a direction. For example, a question like this. This is probably by far one of the most asked questions in the entire world. It's called the Net Promoter Score, and the question goes something like this. How likely is it that you would recommend this something to a friend or a colleague? And then the respondent needs to answer from 0 to 10. The method has actually been very well researched. It has been used often, and there's a lot of research behind it. Nowadays, there are some problems with it that even the original author of the method are starting to doubt that the method is as good as it used to be, but that's a whole other discussion. But what was found out, even initially when this question was made up, was invented, was designed, was that when you ask people this question, they are going to lean towards the better scores. So if someone is actually happy about your product, they're going to answer 9 or 10. These are your active promoters. If someone are neutral, not happy, not happy, not angry about it, they will answer the neutral score of 7 or 8, classified as neutral. And if they're unhappy, they will answer anything from 0 to 6. Of course, the lower, the worse. So that was found out. And that can be used when you're analyzing the data. So you ask people questions like this, they answer. And since we're all skewed to be a bit more optimistic and a bit more friendly when we are answering someone, we have a bias in the way we answer. That's fine because we can correct for this bias in our analysis. But what happens then is that you have all these organizations using these questions to get information about their users, to get information about their own employees' performance, to get information about the performance of the marketing partners and the marketing agencies and stuff like that, then it starts getting a bit complex and the incentives to manipulate with these numbers start to rise. So imagine instead of having it like this for the end user to answer, imagine you did like this in the top. You actually colored the numbers red, yellow, and green. Now you're actively telling the user, oh, if you are happy, you should answer a 9 or 10. And you're telling the user, if you are neutral, you should answer 7 or 8. And if you're unhappy, you should answer 0 to 6. The problem is the original bias in the users, where we tend to answer more positive than we are. It's just going to get doubled now. If I'm neutral, I'm going to see this and say, I'm a bit neutral, but I don't want to punish this company. I don't want to give them a yellow. So I'll give them a 9, even though I'm kind of neutral. And if I'm a little bit unhappy, before I would have said, okay, they're okay. I'll give them 5 out of 10. That's for me. I'm a bit unhappy, but that's okay. But now seeing this, I'm saying, okay, no, I'm not that unhappy. I'm not in the red. I'll give them a 7. So just by coloring the input here, we nudge what people will answer. And there may be some of you guys here sitting here looking at these numbers thinking, isn't that a bit too much of a stretch to think companies would actually try to do stuff like that? And I hope some of you guys are thinking that, because no, it's not. And I can say that with absolute certainty, because this is one of the examples I've been sent in actually numerous forms from previous attendees of this session, examples of how this is being done in real life. And I've brought here also the most grotesque example. Just watch. It's in Danish, so I'll have to translate for you. What this is saying is basically, this is how we measure. Then it says, with big letters here, these 6 means unsatisfied, even with the finger down. There's no doubt about it. These are very bad scores. Then we have the neutral, that's translating itself, and the satisfied. And everything is being colored. Emoticons are added, or icons, and even written descriptions. So it's very, very spelled out, pushing people towards answering even more positive. And more than that, there's also some texts that are very nudging. Let me translate. They start out with the header. We hope that you are happy with your product. That's leading. You put the word happy in the text, and hope, you can almost see them standing there with their big eyes saying, we really, please don't scold us. Please don't be unhappy. We really want you to be happy. That's going to influence the score. Next sentence, you will soon receive an invitation, an email with the opportunity to share your satisfaction. Very positive words as well. There's an opportunity here, and there's an opportunity to share your satisfaction. It's not an opportunity to share your rating or your dissatisfaction. It's an opportunity to share your satisfaction. Again, very, 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 very nudging. Then the next sentence, the company would appreciate if you appreciate positive word again, nudging, if you'd spend 5 minutes on rating your product and add a comment. Well, that's cool. Except asking people to add a comment, people are usually more inclined to do that if they're happy they're more inclined to put more work into it if they're happy. So they're gonna filter out a bit of the unhappy respondents by putting a bit more work into the question. And even more, they even make it very explicit. If you do not give us your product a 9 or a 10, it almost feels like a threat. It almost feels like a threat. If you do not give us a product a 9 or a 10, I hope you can all hear how it feels like they're even almost commanding us to do it. We'd like to hear from you. And it still feels like a threat. I feel like, okay, but what are they going to do to me if I don't answer 9 or 10? Or at the very least, I can see here, oh, if I don't answer 9 or 10, I'm just going to put more work into this. They're going to ask me a bunch of questions. That's just troublesome. Oh, whatever. I'm just going to give it a 9. And that's what they want. Because at the end of the day, this one is not created by someone who wanted an objective truth. This is created by a bunch of guys who want to appear like they are doing good rather than actually do good. So again, nudging, very powerful tool, very, very, very much used tool, and be very wary of it, especially if you're doing it yourself or if your company is doing it, because you're just shooting yourself in the foot. Of course, there's some managers who might get a big bonus. That's the organization's fault if they do that. But as an organization, you will not gain anything from getting overly inflated positive numbers. There's no real learning in that. There's no quality in it. There's no great insights to use. So be wary of nudging. The next example I have is systematic omission. We had a bit of systematic omission in the former example, actually. The point where they started making it more troublesome for those that were already unhappy. Of course, that's going to have some of them drop out of the survey before even answering. But I think one of the most critical examples of this I've ever heard was in the Danish healthcare system. So I was sitting there in my couch watching actually a documentary about the Danish healthcare system when I prepared this session for the first time. And a doctor actually on screen said that they had this survey where every time something went wrong in surgery or with the patient, that could be significant damage to their health, or at the very worst, it could mean the death of a patient. They would have to fill out a form that used for data collection to improve. That's good. That's very good, actually. The problem here in this case was that he said that he actually filled out this form and handed it in to the proper processes, the proper flows, the proper authorities. And then he was pulled into his manager's office, his what is that called again? The head of doctors, the head of yeah. And then they had to go through it. And of course that was troublesome and all, and that in itself could actually have him not write up a new form in the future. But that's not the worst part, because that's just going to give a bit less of a sample. No, the worst part is that the manager directly told him, oh, the form that you filled out, you wrote that it was due to us being understaffed. When the reason is understaffed, we don't actually make these forms. When people die or have damage to their health because of understaff, that's not really supposed to be tracked like that. That was the message from his manager. And this manager probably told that to all the medical residents, interns, and whatever it's called in a hospital, meaning that at the end of the day, the statistics about what is causing these problems would be very much biased towards not showing resources being a problem. And one can only speculate if this desire to this not come out as a problem comes from the very top of the managers all the way to the head of the the healthcare system. But that's purely speculation. Problem here is that if you have some sort of data collection, you should be not only attentive about data that is coming in, but you should also be very attentive about the data that is not coming in. The data that may be left out because other people have incentive to leave it out. The data that's being left out because people couldn't be asked to fill it out. Another example could be you have an ERP system. People are being asked to enter data. But if one employee is more keen on doing that than the others, and therefore they write 90% of the work that's entered into that system, well, that means their way of interpreting everything is, of course, being more dominant in that data. So be careful about the data that is not being collected. Yeah, so if you had a guy who worked in quality assurance, of course they would be more interested in adding in good quality data, for example. So that was omission. So in data collection, there's also the good old no source data. And here we are back to our all what we all love and hate, our old tool Excel. It's not only Excel, it's also it can also be a problem within Power BI or even your data warehouse actually. The problem I'm trying to describe here is the problem of data with no source. If you're handed an Excel sheet with aggregation of sales numbers for last year and this year, but that you have no way of tracking how was it aggregated, where does it come from, how was it filtered, what happened during the route of this data from its collection to us sitting here with it. There's no source, there's no lineage. It's very hard to know if you can trust this data. And then suddenly you need to trust the person who made the data more than you need to trust the data itself. And I think that's one of the biggest problems out there. And I think that even us as data practitioners don't always make sure there is a clear lineage in the data architectures, the data pipelines we are creating. And I think there's that we should all actually put more emphasis on that. Because a lot of decisions are taken on data that the decision maker just blindly trusts, and that's a big risk. Okay. I also have here a funny example of a combination of data collection and storytelling. And I usually call this pushing data. And it's a phenomenon I've been aware of when working with sales management systems, CRM systems, and stuff like that. And I have here an example. Let's say we put on the malicious, the bad guy hat, and we say we are a salesperson who wants our statistics to look better. And we know that our organization is tracking our numbers in the following manner. There's a list of sales month to month, and then there's a metric of month-over-month percentage. So in this case, if we had 3 months with the same sales, 100 units each month, we would have a month-over-month percentage of 0%, meaning no growth. Okay. So let's imagine that this is actually the case. We are not the best salesperson in the world, or we are very experienced and we're just not seeing the growth we used to do. But we would like to fiddle with these numbers so that they look better for our, it could be our next salary negotiation. So what can we do? So this is, we have a fixed number of sales. I mean, we cannot change the sales that we're making. These are, of course we can. In real life, you should probably just try to do better. But nevertheless, the assumption here is we have a fixed amount of sales in these 3 months. can we make our data appear to just look better by just pushing some of these sales opportunities around? Well, let's test it out. Let's try to move 10. So the sales are supposed to be closing by the end of February. How about I just make a quick call to the customer saying, well, you know what? I'll send you the contract next Monday, 1st of March. Everything will be fine, yada, yada, yada. And then we close the sale in March instead of February. Customer is fine with that, doesn't really care. It doesn't change anything for him. So we do that. So what will happen in our month-over-month percentage? And I know this is as much a problem with using month-over-month percentage as a metric, but nevertheless, it is being done. So suddenly it's going to appear like we have a drop of 10% growth in February, but then we pick up and more in March. So at the end of the day, it fell down by 10%, but we got a huge increase in March. So probably there's some not so data literate managers sitting there clapping his hands saying, that was pretty good. Good job in March. That's a good comeback. And it actually works the other way around as well. That's the funny thing about numbers. The funny thing is you don't even need to push the data. What if you just actually pummeled your own sale? You called the customer and said, you know what? I don't want to sell to you. You stink. Something like that. Just completely mess up that one sale for 10 units. So you're going to end up with a net negative amount of units sold than in the baseline. Well, your percentages are still going to look like you ended up back to where you started. You're going to have minus 10% and you're going to have plus 11%, even though you actually did worse. Of course, again, it's a problem with the way we're calculating month over month and that we're comparing that on percentages, but I've seen it happen. And we can push it further and be even more creative with this data. Do stuff like moving it up, moving it down, moving stuff from March to February, and we're going to have numbers that begin to look obscure and it's hard to find out. But with the same numbers, again, the average here is 100, 100, 100, 100 each month. It's just going to look like we have some pretty good numbers. Yeah, it's going up 20%, going down 33%, and then up 25%. And again, the data illiterate manager may just not by choice, but he may subconsciously start adding these numbers together. Oh, so this 20 plus 25, that's 45. 45 is a lot more than 33. So yeah, that's actually pretty good at the end of the day, even though it is very, very, very neutral. So yeah, pushing data, it's a great way of having your percentages look in your favor. And yeah, and it has been seen, it has been done, it happens. And what do we have? And it doesn't matter if you like go up, then down, then up, or if you go down, then up, then up, then down. The only thing that matters is when you're talking about percentages and a baseline month over month percentage, volatility is just going to make your percentages appear better. That's just how it is. You can also go, yeah, down 20%, then a bit up, then a bit more up, and you're going to have something that looks like this. Oh, down 20%, but we more than got that back again. And then even better in April, even though, again, if you sum up the numbers, the average of all these four is still 100. So again, none of the actual data has changed. We just pushed the data to different months. Yep. A neat way to manipulate your sales data if you have a company that are over relying on month over month or year over year or whatever percentage based comparisons. So if you are indeed in a company or an organization that tends to be very focused on percentages like this, try to look into them and see if there are being used logically or if people are using them in a flawed manner. That was it for data collection. So we can take here 10 seconds just waiting here if you have any questions, if you have any other examples of manipulated data in the data collection process. I would be very happy to hear about it. I'm guessing there was no questions, or I would have heard. You said no?
Nope, no questions.
No questions. Well, we'll move on then. So that was data collection. So already at the first part of where we collect the data, there's so much manipulation and cherry picking and sampling and stuff like that we can do. And that's even before we start turning the data into insights. So let's try to turn the data into insights. Did you say anything? Oh, no, great. Let's turn data into insights. Okay. Let's imagine that we are a guy in a company supposed to be having a presentation about our financial performance. Maybe it's in an investors, I don't know the term, what is called investor summit, investor meeting, something like that. We need to present how it's going. And the numbers look like this. What do we do? Because this does not look very good. No matter how we slice and dice these numbers, this is not good. Think about it for a second. What can we do? Again, we don't care about ethics. We don't care about deception. Actually, we want to do that. What can we do to the numbers? Well, we'll just change the format of how we present them a bit. Let's make them cumulative. Let's just add them together month over month. The data is still correct, technically correct. Each month we have the accumulated sum of the entire year's sales. It's going up, it's going up, it's going up. Of course, I mean, which company doesn't sell a single unit in a quarter? So of course it's going to go up, up, up. The data literate viewer may be able to spot that, yeah, it's going up, 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 but there is something going on here. It's dipping. It's not linearly rising. It's very much more obscured than before, but it can still be seen. So let's try to blur it out a bit more. Maybe we change the format to an area chart. There's still too much sharp thing going on here. But what if we add some gradient to this area chart? Can we take away a bit of the emphasis on this decline? I think we can. Yeah, I think we can. We end up with this. I hope some of you are sitting now and thinking, but no one is going to fall for this. I mean, this is just too obvious. Of course, I mean, any decent person with common knowledge is going to detect that this is bad. These are bad sales numbers. Well, I think if you're thinking that, I think you're overestimating the data literacy of the average consumer of data. And if you're in doubt that this has ever been done before, well, I have definite proof that it has here. So I don't remember when it's from, but it's from a few years ago. Sales of iPhone, cumulative iPhone sales is being presented here exactly in this manner. You have the rising area chart cumulatively or year over year, and then at the end of it, you can kind of slightly spot that it has a declining slope here. Kind of hard to spot if you're not using a ruler or something like that. Very cleverly done. So if the guy for one of the most famous brands out there is using this for his presentations, I can bet you that it's a commonly used trick out there in the world. So if you ever see a chart that seems a bit out of place, something is being accumulated, something is being a area chart where it should have been a line chart, just think about for a second why the author of that chart would want it to look like that. Could be that they just don't know the way around data visualization, but it also very well could be that they really do know the data visualization and that they are intently trying to mislead. Not saying it's the case here, but it does look like it. All right, that was accumulating your numbers. We can also play around with the axis. So we have three libraries here, library A, library B, library C. We are the owner of, or not the owner, the manager of library A, and we want it to look like we are doing so much better than our competition or co-workers, or how we treat this. Well, how about instead of letting the y-axis go to 0, we just start from 3000, and suddenly the numbers look vastly different. It's a commonly used examples. I think you've all accidentally done this, also because stuff like Power BI tend to do this by default if you don't actually null the y-axis yourself. So, or zero the y-axis yourself. So be aware that any y-axis not starting at 0, be suspicious. We can do other things. We can actually also manipulate the x-axis, not as commonly used, but look at these crime statistics. There's a slight increase in crime every year, quite linearly. I mean, it's rising, but it's not newsworthy. But maybe we're running a newspaper and we want to make it newsworthy. What do? We just change the x-axis. Skip a few years, compress the last bit, and suddenly we have something that seems just spiraling out of control. Very easy trick. Yeah. We can also do it by adding more white space to our graph. So look at these home prices here. They have been steadily increasing, a little bit of an exponential increase. It doesn't seem that crazy. But what if we add some context we don't actually show in the graph? What if we add a bit more of a date period here? Suddenly the increase seems massive. I mean, wow, that's crazy. Compared to this seems almost flat, but it's just soaring up to the skies. But I mean, it's the same data. So yeah, again, white space in a chart could be deceptive. It could also be an accident. But yeah, be aware that it's going to change the story that you're telling. And then we also have dueling axes. So two different axes crossing over each other with different numbers. That's almost always going to be misleading. For example, here, cancer screenings going down and abortions going up. So these are numbers from the what's it called again? Planned Parenthood in the United States. So this was brought to an actual Congress hearing, saying that it's a big problem that they're doing more and more abortions, but they're doing less and less cancer screenings. So they should be punished for that, or whatever was discussed in this meeting. But the truth is, if we look at the actual objective data, that cancer screenings, yes, they are going down, but abortions are almost not going up, if not only a bit slight, and definitely not crossing paths where one is being done more than the other. So again, a very misled data here, which actually caused a bit of debate in that congressional hearing. You would think that most congressmen saw through this immediately, but I mean, it's politics, so they did not. Someone very much made the arguments that they should not be doing more abortions than they did cancer screenings. Well, one more thing I'd like to add is aesthetics can actually be used for misleading the data or the data storytelling. So I don't think this is a particularly very much a misleading data. I just want to point out that it looks very pretty. Probably one of the prettiest way of visualizing an annual revenue I've ever seen. But the fact that it's 3D and that it's kind of diagonal makes it very hard to compare the tops of these things and actually know how much revenue are in each of them. So it makes it hard to compare. And these two looks like they have the same height, but they're actually very much apart. So the message here is just avoid making your aesthetics come in the way of good objective data storytelling, and be aware if something is very aesthetically pleasing, that can actually blur the storytelling behind it, and there could be some malicious intent in it. In this case, I don't think so, because they're actually making their numbers seem a bit worse than they are by doing this. So yeah, but I can only speculate. So that was storytelling. Next, we're going to move up to context. And in context, I have the most clear context I can find is comparisons. So when we compare two different things, and we've just been through a long period where data visualization just got a lot more popular than it had ever been, because we were all looking at data from COVID. So I have here two different charts. I don't want to get into the realm of discussing the politics in it. I don't necessarily agree with either one of the charts, but I just want to show you here there are two vastly different data stories or storytelling with very similar data. So one here has, it's in Dutch. One here has the amount of infected people, and then in red line here, the amount of death with a shared axis. So obviously the deaths are going to look minuscule. On the other side, we have a list of vaccinated people and then a list of death where deaths are very, very much taking up a lot of space. And we're comparing percentages to absolute numbers. So that's, even though it tells a clear story about a correlation, it still makes these deaths seems like a massive number compared to the amount of death here, how they are being represented. So I'm just saying that when you compare two numbers, the choice of contextualizing, putting them together, that's also part of your data story. And it's also part of what message you're giving. And it's where things start to be hard to be objective about, because I don't see a clear middle ground between the two either, where I would say that is just objectively the least misleading way to represent this data. Data visualization does inherently have some component of storytelling and subjectivity. It's hard to avoid. Other comparisons? 26% more juice. I think we've all seen these in a lot of commercials. The question here is, well, compared to what? And usually these juice or soda or whatever companies, they are actually comparing to what's it called? Juice that's been processed in a different manner. So for example, juice that is being pressed for a longer time versus shorter time or stuff like that. It's not necessarily compared to their biggest competitor or something like that. It's usually compared to some very, very, very small baseline they can find. I think in one case it was compared to if you'd pressed the fruits by hand yourself at home. Yeah, I don't know. So yeah, when there are comparisons between two things, be on the lookout if it's not being mentioned what the other thing is, because then there's nonsensical. Then we also have absolute and relative comparison. It's one of my favorites actually, because I even fell for this one initially. And these are the numbers from before. And I don't think a lot of you guys were very skeptical when you saw all these numbers. And I don't think a lot of you guys were very skeptical about my conclusion of crime going up, because crime is going up. But there's something missing here. And again, when we talk about context, be on the lookout for what is missing. Can anyone in the chat guess what is missing before I show the next slide? Is it a silent chat again, Kevin?
So Zelly actually says density or population.
Yes, very good. That is exactly right. So we have again same thing on a country basis. Some areas here look very bad in aggravated assaults, but if you then look at the population of the county versus the number of assaults in the county, you'll see that they look almost identical. Because of course, if you have more people in a county or in a state or in an area, of course you're gonna have more crime. That's logical. I mean, unless other things are influenced. But I mean, at the base of it, more people will on average give more crime because there's more people. So if you compensate here and look at it per capita, very much different chart. And again, the same thing from the crime. If you actually report it now per density of the population, you have the complete opposite data story. Crime is going down rapidly. I mean, not as rapidly as we're seeing, because once again, the axis here has been rigged. But I mean, crimes are going down. So be on the lookout of what is not there. In this case, population was not part of it. There was a key driving by variable metric here that was left out. And crime increase in itself is not a good metric for crime reports. The quantity of crime reports itself is not a good metric for comparing crime year over year, because each year will not have the same context. Another contextual thing is timing. And when I say timing, I mean, when will I make a report? When will someone make a report on some data? If the company is scheduling the same report every quarter, that's fine. And I think that's why, as a society, we kind of tend to do that with financial reports. They have to be done quarterly. They have to be done annually, because you cannot choose the timing then. If an employee wanted to promote his own effort, a good way would be to make an ad hoc report of what he had done. So let's say I'm a sales guy and I just learned about some Power BI or stuff like that. I had some really great month. So I get this great idea of creating a report that showed our performance month over month. And I share it with my manager, and he looks at the number and he's pretty happy about my results. But I chose to make that report because I was excited about my own sales numbers. Would I have made and shared that report in a period where I was doing bad? Of course not. I wouldn't. So I chose the timing of when to present my manager with some insights, with some data. So again, timing matters. If someone is handing you a piece of data, think about why and why now. And again, if you have some very important things to measure, consider putting it on a schedule, because that's going to prevent timing as a means of manipulating the data story. These were all the examples for today. I hope you like them, and I hope you have some more in your toolbox, some more examples in your toolbox of what you can be on the lookout for, what you can spot out there when you're creating your own reports or when you're looking at others' reports. And when we look at how we want to prevent this manipulation, I think there's one thing we need to do before anything else. And it's a hard pill to swallow. I think we need to accept that it happens. And I think that we need to accept that we also do it. Because as I said before, storytelling is a bit subjective. We can do things to objectify it. We can make fixed schedules. We can use international standards of reporting. Actually, when you hear me say them out, a lot of these things are being done with quarterly financial reports, stuff like that. Things are being standardized so that you cannot manipulate them. Not that they are not being manipulated, but they are just being manipulated within those frameworks then. But it happens all the time. It happens maliciously, and it happens by accident, and it happens innocently. So be skeptical. Then I think when we have accepted that it happens, there's things we can do. We can do data literacy training. We can train ourselves. We can read up on more books on this topic. We can see more sessions on the topic. We can just in general learn data literacy. Definitely recommend everyone to read some books on critical thinking, because that's going also to change your mind of being being critical of what you see, and always think about where does it come from, what's the intent behind it, stuff like that. I think there's a lot to be gained in having systemic methodologies around decision makings, especially for big decisions. So, I mean, gut feeling is probably the worst offender for, or the most vulnerable thing for data manipulation. You see some numbers, you take a decision based on your new gut feeling, because you let those numbers influence you. If you can have a systemic methodology, it can safeguard that as well. Traceability in your data. So again, data lineage, tracing the source, everything around that, very important. And the kind of synergizes with data literacy. The more lineage you have, the more people can start investigating where the data come from. The more they investigate where the data come from, the more they learn about data, and so on and so on. Having audits of historical data is also a good way to make sure that people are not pushing around sales orders, for example, or any other way you can manipulate data by pushing it back and forth, or blowing up the value of a sales opportunity or stuff like that, then decreasing it and again, and all these things. Those can be checked out if you have historical data records. And what can we do as individuals? Well, we can be critical about what sources, what we get the information, where it comes from, who sent it to us. Could they have been getting it from a third party without being critical? Could they have an intent with this piece of data, piece of insight, piece of persuasion? Who prepared it? Can we trace where the data come from? Ask all these questions, or at least think about them. And think about what is left out. That's always going to, or almost always going to, show you some footprints of what could have been manipulated. Then think about the coherence between the data, the insights, and your hypotheses and conclusions. Don't just be spoon-fed with data that's not that is. Don't let yourself be fed only with data that supports what you initially thought. Try to be objective about collecting data that is putting both views of a topic. And then at the end of the day, does it make sense? It's okay to use your common knowledge, but also be equally aware of your biases. That was it from me today. That was it from me for today. I hope you all enjoyed the session, and I'm open for some questions, and we also need to do the raffle. So I think, Kevin, if there's no questions, you can take over from here.
There actually is a question.
Oh, cool.
I know you're excited. Does this mean that one should look for the phrase per capita for the most accurate analysis? If so, what are other rules of thumb to look for accurate visualizations? Or are there any?
So I wouldn't necessarily look for per capita in everything I see, but I will always ask myself the question, could something have been left out? So if I'm looking at, that's kind of the same principle, but if I'm looking at statistics about products and when they broke down quality assurance data or stuff like that, it's important that we make sure that the percentages of these breakdowns that could happen are being, again, compared to how many of the products that are being sent out in the field. So if so just ask yourself the question, what could be missing? What could have been left out? That's my rule of thumb.